Hello, everyone. It's a pleasure to be here. Thank you so much to everyone for having me, and I hope you're all safe behind the screen. It's a pleasure to meet you all, and welcome to this adventure of Kotlin and Compose through the multi-platform world. Before we dive in, I just wanted to give you a brief overview. So my name is Carlos Mota. You can find me at Twitter at CFonsMota. I usually tweet about Kotlin, about Android, about some pictures from some trip that I've made. So feel free to follow me there. I've been programming for Android for the past 13 years. Yes, it's already a big number. I'm an Android GDE. I've been a Kotlin and KMP advocate, so I've been working with Kotlin multi-platform for the past 5 years, and initially as a side project, and for the past three as my side project and daily project. I'm also community driven. I'm an author at Dev, previously Hey Wonderlic, and I love to travel, photography, and running. So it's not only software. I also have a passion for travel, photography, and that occasional run. For this talk, I've created a couple of slides, so you can find the slides on Speaker Deck. I've also created a sample project that you can go in on my GitHub under semota/unsplash, and you can check and run what I've been teaching you during this talk. I've also written a book if you're interested to know more about Kotlin multi-platform, and I'm trying to have a YouTube channel and try to post from time to time. So feel free to subscribe my YouTube channel. So let me start with a question to all of you. How do you develop an app? If you want to become an app developer, if you want to have the next app on the store, how are you going to do it? So there are a couple of steps in order to develop an app. And we can perhaps think about the first one as you need to have an idea. Or perhaps you want to earn some money and you're just going to try something. Or you might want just to test a new library or a new framework that was released, and you're going to just create an application to it as your test case. So the first thing that's important when you're going to develop an app is to define the requirements. So the type, is it a POC? Is it a proof of concept that you want to build? Something that you just want to create something small to see if it works, and you're not going to make anything big out of it. Do you need to build an MVP? Do you need to build something just to showcase pretty quick on all the platforms and to validate an idea? Are you going to target just one platform, or are you going to target all of them? And are you going to have time to develop a specific platform, a specific application for each platform? Or once again, needs to be something fast that you need just to release to the market or to a client? It's also important to think that if you're developing a project, that project or that app is going to be for the next year, or it's going to be the next 5 years, or do you hope it's going to be forever? So these two groups are the things that you need to think before starting to develop an app, just to decide which is the best tool for you. Depending on these two groups, you might think that one is preferred over the other. So the second thing is you need a group of people to help you with a talk, with your presentation, with your app. And depends a bit on the team that you have. So are you going to have a team? Are you going to be the only developer? If you're going to be the only developer, it's going to be pretty difficult to create like 2 or 3 different applications and to write and rewrite the same thing over and over and over again. So if you're going to have a team, what's their background? Are they web developers? Are they Android developers, iOS developers? What's their background? Also, the team size is important. Imagine that you want to target Android, iOS, web, and desktop. Can you have at least 4 elements, one per platform, or are you can only have 2 elements and one for Android and desktop and another for iOS and web, for instance? So now that we've defined that we need a set of requirements, you're a team, it's important to understand to where you're going to publish your application. So the first thing is the project that you want to do, have a good deadline for you to work on it. Or are you already behind schedule and you need to do things pretty fast? Because if you have some time, you might be having time to look and learn a new technology. Otherwise, you need to use the technology that you already know. Also, is there going to be any budget on your project? Can you hire or allocate more people to your project? Or once again, there is constraints that doesn't allow you to hire more people and you just need to start working on it immediately. And now the important part is, are you going to target just for Android or just for a platform, or do you want to target multiple platforms? So since you need to talk about multi-platforms, there are several tools that exist for quite some time that can help you in this process. In this slide, you've got, for instance, Ionic, Xamarin, React Native, Flutter, Kotlin Multiplatform. There are different tools that, depending on what you like and what you want to develop, might or not help you. So I'm going to start with just showing you a simple example. So this slide and this image represents sharing a video from Instagram to Facebook. And I'm going to play it again. I don't know if you notice, but pay close attention to the second spinner. So this one. So that's exactly one of the problems of using one of the cross-platform solutions. So that spinner, out of curiosity, it's from Android 2.3. So it means that spinner perhaps has more than 10 years, and someone from Facebook, from Meta, forgot to update that component. And this is just a small example, but you can see that it's not the best experience for the user, that he was seeing good, a clean UI. He saw a spinner that corresponds to the spinner that he saw on his or her app. And then out of a sudden, he sees a component that it's, I'm going to say, ugly, but you can go with out of touch, a component that existed for 10 years back that someone forgot to update or didn't have the time to update. And this is one of the problems when we're using these type of solutions, that sometimes you're using a modern phone, you're using the latest OS with the Material Tree on Android or the Cupertino Design System on iOS, and then there is a component that doesn't feel right because it's from a previous version. There's also another problem. So this is an iPhone that's running an application that was built in Flutter, and typically Android users are more friendly with this, and they don't mind to see from one time or the other something that's more iOS specific. But iOS users don't really like to see components and UI that's not iOS specific, and this is what happens. So someone built a library for Android and iOS using Flutter, and the component that they selected to build the UI, to select for a country, was a dialog that's from Android and not from iOS. So you're using an iOS app and you might miss something because the UX is not the one that you were looking for. And for the end user, it sometimes, this is just a simple example, but sometimes it might make a difference between using your app or another app that was developed natively. Frameworks like this one, and trust me, what I'm going to say here, it's also valid for me. Be careful with the demo effect. Sometimes when you're watching a talk, you see that something was built under 40 minutes. So this is the way to go. This is great. And then you're going to try it on your use case, and you realize that those 40 minutes basically became 3, 4, and 5 days, and you're still trying to have the same experience and the same thing that you saw on the presentation. So be careful when people are selling out frameworks or tools, because yeah, developers advocates try to make that perfect world, but sometimes things are way more difficult than they're explaining. I also think that you might become framework dependent. So I've got here an example. A couple of years ago, perhaps 6 or 7 years ago, I was building an app using Xamarin at the time. And there was a huge redesign on iOS. Everything changed. I don't exactly remember which iOS version it was, but it was when that button for calls became like that really light green. And so all the apps that you're using native components, when you were running on a new OS, you could see those new white components that were prettier, that were according to the that version of OS. And my app that was built using Xamarin, since when you're using one of these tools, you're not using native components and you're using widgets that these tools create, these frameworks create. When the app was running on this new OS, so everyone was still seeing the old components and complaining that their app was the only one or one of the few that didn't look like it was updated to the new OS, and they wanted to know why. And then I needed to wait 5 months for these new widgets to be released. When they were released, I needed to compile the app again, submit it to the store, wait for Apple to approve it, and then wait for the users to install this new update. And I can tell you that along this way, and this was just a simple application, I lost like 40% of the users that I had before, with a lot of complaints saying that it didn't look pretty because it was going against the system and they prefer to install a different application. And I learned my lesson since then and never used one of these tools, never again. So I usually develop things natively. Sometimes there are features that are missing. Imagine that you want to do something that's more Android specific and not it doesn't exist on both platforms. Typically, you need to implement it yourself. So that beautiful world that everything exists and you can share the code base between both platforms, it's true, but sometimes you also need to implement specific things because they're not available. I know that this point now is going to be arguable. So people are going to say that they do not feel that they have a slower performance, but to be honest, you've got a layer in between. There are some of these frameworks are better than the others, of course, but you're always going to have a smaller performance. This slower performance might be in case of some of these frameworks, like Flutter can be a bit okay. It's not important because you're not almost seeing it, but it exists. And talking about Flutter, one of the comments that I've seen quite recently to understand if an application was a Flutter application was basically to try to drag or to scroll the screen with 2 fingers, and you could see that that animation is not as smooth as working with a native application. Once again, this is a small thing, but is a thing that people notice when they're using your app daily. That something is not quite yet there. Also, you're committing your entire code to one framework. And this is something that I always fear about this if I'm going to work on a project that's going to be like 10-year long project or 5-year long project, which is what's going to happen in 5 years? Is that framework still going to exist and be maintained? Or am I going to rewrite everything? And I also need to implement things on the framework side because that framework is not maintained as it should, or I'm going to rewrite everything. What's going to happen at that moment? So these type of things are all things that you need to be careful when selecting one of these tools. Of course, that here in this talk, I'm going to talk about Kotlin Multiplatform and Compose Multiplatform, so it's what I'm going to advocate. But any of these tools might make sense on your project, once again, depending on the type of project that you want to build, your team, if you have budget, constraints, requirements, and the number of platforms that you want to reach. So I'm going to advocate here Kotlin. Kotlin is a language that we all love. Yes, thank you, Mac, for this amazing emoji. So let's talk a bit about Kotlin Multiplatform. So the first thing, and if you compare with the other tools that I've mentioned, so Kotlin is it's not a framework, it's an SDK. This is an important point. And it's, of course, developed, as the name indicates, in Kotlin. That I also saw another user with a love for Kotlin, so that's the way to go. And the great thing about Kotlin Multiplatform is that it doesn't intend to share everything. So while if you're doing something with Xamarin or Flutter, you want to have a single code base that's shared across Android, iOS, desktop, and so on. The goal of Kotlin Multiplatform the goal with Kotlin Multiplatform is to share what you want to share. So you can share just your network access, or you can share, for instance, your database access, and you can just share a small part, like for that specific feature that you're now building, or you can share the entire thing. It's up to you what you want to share. So this is great for another third part, which is, imagine that you're switching to multi-platform and it doesn't work for you. So you always have, first, you didn't commit your entire project to multi-platform. So it's great because you didn't allocate that much time. And second, if it for some reason fails, that I doubt it, you always have that code that will run on Android. While if you develop for Flutter, for instance, and if it fails, you don't have that code, you cannot just have it for Android. No, you need to rewrite everything on Android. In this case, you can reuse almost everything. Also, it's important to mention that although we're going to have composed multi-platform, Kotlin multi-platform was built just to share your business logic. The UI should be developed natively, or alternatively, you can develop your UI using any of those tools. So you can use Flutter for the UI while using Kotlin multi-platform on the business logic. So there are a couple of words if you search about Kotlin multi-platform online. The first one that should pop up is KMP, which means Kotlin multi-platform. But you can also see other words like MPP, which was multi-platform and it was dropped. And you can also see on some more recent blog posts, KMM. KMM standard for Kotlin multi-platform mobile, and that was just for iOS and Android. But JetBrains decided to drop the name and just consider the whole thing to be Kotlin multi-platform. So when we talk about Kotlin multi-platform, we have WASM, WebAssembly, we have JS, we have the JVM. With our desktop apps, we have native and we have Android. And here inside native, we have Linux, Windows, macOS, iOS, tvOS, watchOS. And in Android, of course, we also have all the platforms that Android runs on. So we've got TV, Wear, Auto, Automotive, and if there's an Android fridge, I'm sure it's also going to run KMP over there. So I know that after just this couple of minutes of what I've been saying, you all want to start with playing with Kotlin multi-platform. That's the way to go. And you've got two possibilities here. The first one, and on my opinion, right now the easiest one, is using Android Studio. This is the IDE that we use for Android development, but there is a plugin called the Kotlin multi-platform mobile plugin that you can install, and it allows you to create a project from scratch. So when we install this plugin, you restart Android Studio, open it again, and if you go to new project, you're going to see Kotlin multi-platform app, and then you can start your application. If you want to target iOS or anything native for Mac OS and so on, you need to have a Mac for that at this moment. Although it's on the JetBrains roadmap for Kotlin multi-platform, that in the future this won't be necessary. So if you want to try Android and iOS, you can just go to Kotlin multi-platform app and run your app on Android and on iOS simulator. From the example, you're just going to see a hello Android and a hello iOS to see that you've got the same code that adapts to the platform where it's running. It's also important to mention that Kotlin multi-platform went stable 2 weeks ago. And since then, JetBrains has been launching a lot of things. One of those things was Fleet, which is going to perhaps replace Android Studio for multi-platform development. It's still on its early stages. People were used to Android Studio, and one of the great advantages of Fleet is that you can work on Android and iOS there, so on Android code and Swift code, but it's still on its early stages, so it has like less than 2 weeks. But the feedback so far has been really, really good. If you want to create a more complex application, there is also a second template. This template was created by a great company that has been working with Kotlin multi-platform since day one, which is called the TouchLab, and or TouchLab, and the template that they use is the Camp Kit. You can go to this GitHub and start your project from there. So this template has a lot of libraries. It also has network access, the dependency injection, all of those tools that you might end use on your application. It's already on their template. They also maintain the template, which is great because you're always going to have the latest features and using the latest libraries and versions. So now that you know how to start, let me show you how you can have different behaviors on different platforms. So I was mentioning that when you open your app with on Android, you're going to see hello Android, and you also want to see hello iOS, hello desktop, hello web, hello follow the platform that you want to show, where you want to run your app. So the first thing that if there's something that's going to be platform specific, you need to use a specific keyword called expect. And this expect means that you, as the name indicates, you expect someone is going to define what in this case name is. If you look at the path, you're going to see that this code is under source common main. And this common main is where all the common code is going to be located. So all the expect declarations are going to be defined inside this common main. So once again, if in this case, allow Android, you want Android to be platform specific, and you need for all the targets, all the platforms that you're going to run your app, they need to define what name is going to be. So you use the keyword expect, and then you define a property called name. Now, since we're targeting Android, desktop, and the web, I need to define what name is in each one of those platforms. Let's see how can we do this. So if I'm running on Android, first look at the path. It's no longer common main and it's Android main. So this is every time that you switch targets, you're going to see Android main, iOS main, GS main, depending on the target that you're going to run. And now you're going to see a specific keyword called actual. So when you define a specific value, you use the keyword actually. So once again, expect to say that someone needs to define this, actual to really define its content. If you're targeting, for instance, iOS and you don't define what actual means for iOS, your project won't compile. So you have the guarantee that you're not going to compile the project with something missing. The IDE and or the compiler in this case is going to always tell you, okay, if you're defining an expect and if you're targeting Android and iOS, you need to define actual for both cases. So now if you want to define for desktop and the web, once again, we go to desktop and we define a name for desktop, and for the web, and we define actual for the web. So everything that you're going to do that's platform specific, you can do like expect actual. This is not an interface. This is way optimized underneath. And when you're going to run your app, for instance, on Android, you're not going to have your iOS code or your desktop code over there. So your final library will not increase its size because you've defined on your project multiple targets. Talking about libraries that you can use, on Android, for instance, if you wanted to use databases, you'd use Room. On iOS, you'd use Core Data. On the web, you'd use so many other things. Retrofit for web and Alarmifier, JSON or Mosin and JSON serialization for serialization, RxEver, RxSwift, tests are on both platforms. And on the side of Android, you've got the activity. On iOS, you've got the view. And now with Compose and SwiftUI, you've got the lazy column and the lazy edge stack. So now with Compose Multiplatform, imagine that you want to move all your business logic to Kotlin Multiplatform. Instead of having those tools with like Home, you're going to use SQLite. Instead of Alarmifier or Retrofit, you're going to have Ktor. For serialization, Kotlin X serialization, Kotlin X routines for the requests, and Kotlin tests to make tests on your app. And then your UI part is going to be the same. So you're still going to have the activities or the views, the lazy column, and the lazy edge stack if you're talking about Compose and SwiftUI. And of course, in the web, there are a lot of frameworks that you can use. I'm not going to go through all of them. This is just an example to say that you're on the UI side, you can still use everything like you did before. In case of your business logic, you can use any of these libraries. So there are a lot of libraries out there. There are some powered by JetBrains, like the coroutines, serialization, datetime, atomic foo, and so on. For the network, typically we use Ktor, and the community is building a lot of tools that nowadays exist in a lot of production apps. Perhaps one of the most important ones is SQLite, which was created by Cache app. And there's also important to mention a couple of libraries that we're going to see a bit of further in detail, which is the Mocha resources that allows you to share your resource files, so your images, strings, and so on, between multiple platforms. You also have the settings, which allows you to use Android chat preference and iOS end user defaults on multi-platform side. You've got a GraphQL, dependency injection like Coin, and so on. This list is getting bigger by the day, and there is a link on GitHub called the KMM Awesome, where people are just publishing new libraries that they're building. And trust me, I'm going to say weekly, but I could almost say daily that new releases are being launched and be added to this file. So a couple of suggestions out there when we want to work with Kotlin multi-platform. This is already exists for quite some times, but use the new Kotlin native memory model. Kotlin is currently on 1.9.20, and I have to think about this because 1.9.20 it's considered to be the stable release of Kotlin, and it was released 2 weeks ago. And 2 days ago, while I was doing this presentation, 2.0.0 beta 1 was released. So it perhaps in the middle next week or the week after, you're going to have the 2.0.0 stable release, which is great because you can see that so many features have been added and the platform is so stable at this moment. That's also a great push for new developers to start working with Kotlin and with Kotlin multi-platform. For iOS developers, I always advise to export your libraries. Sometimes it's a bit tricky to convince iOS developers to start working with Kotlin multi-platform. The way that we didn't, it worked really, really well was at the time, iOS developers wanted to learn SwiftUI, but we had a bit of constraints in terms of time, so there wasn't that much time that they could use to learn. So we started creating part of our business logic on the shared model, so using Kotlin multi-platform, and they had those weeks to learn how to use SwiftUI. And once they have learned and start building their apps using or their UI using SwiftUI, they already had the business logic ready and they could just interact with the business logic. So from the management part of view, there was no time. We were still on time. There was no time lost. And they could learn how to use a new thing that they wanted to use. And at the same time, we wanted to push a bit with Kotlin multi-platform, and they accepted. And now they have a lot of multi-platform libraries on their projects. Also good argument is about core data. So a lot of iOS developers are not big fans of core data. You can sell this to them. Okay, start with this is a thing called SQLite. This is great. It already handles everything. And as soon as they get in love with SQLite and don't need to worry about core data, you can just keep pushing new things to them. Also, an advice when you're compiling for iOS and when you're compiling the library, or in this case, the framework, it takes some time. So there are a couple of tips that I can give you to improve. For instance, compile only the frameworks that you're going to use. So if you're targeting the simulator and your device, just compile the one that you're targeting. So if it's the simulator, just compile for simulator. If it's the device, of course, just compile for the device. And if you're building multiple frameworks like debug and release, just compile the debug framework. You don't need a release framework for your daily development. Also, I always advise that each framework should have its own repo. It should be on CI, and you should be able to just create a Swift package and import it on your app. If your iOS app is still using Cocoa Pods, you can also have support for Cocoa Pods and generate your framework with Cocoa Pods.
Hi, Carlos. We just have a question from Zareen. They say they're quite new to web development and they were wondering what it means for Kotlin multi-platform to be stable.
Okay, so that's a great question. And So we start to have Kotlin Multiplatform. It was released a couple of years ago. And I would say that perhaps 4 or 5 years ago, we start seeing apps in production using Kotlin Multiplatform and big applications. So Cash App has had part of their code on Multiplatform. You've got, for instance, JetBrains Space App was full multi-platform. Yandex Maps was also multi-platform. So at the time, it was considered to be alpha or beta, depending when it was, because there were still a few things that needed to be improved. For instance, when I mentioned before, the Kotlin native memory model was when Kotlin was initially introduced for multi-platform, it was single-threaded. There was no support on the iOS side to have multi-threaded. That was fixed, or that support was given on 1.6.10, if I'm not mistaken. And we reached beta around that point because you could have the same features and functionalities that a native developer could have. So basically, these beta were kept in beta because there were always things that needed to be improved, and JetBrains didn't feel that it had a level of maturity to be called stable. Because when you call stable to a release, you cannot. Users have a bigger expectations, or developers have a bigger expectation, and they don't want to see issues. And when you're building a big tool like this, a big SDK that's going to run on all the platforms, it's common to have issues on the beginning. So it needs a level of maturity, of stabilization that only happens with a lot of companies and users using their tools. So only now, so I'm going to say 5 years after, they consider that it was mature enough, that there wasn't any big issues, and it could be considerable stable. That's why 2 weeks ago we reached 1.9.20, and the stable, it's like more of a flag saying, okay, if companies want to use this now, they can. We've got a lot of apps already using it. They are happy with the results. We're happy with the results. Please, we use Kotlin Multiplatform on your projects because it has our stamp for approval, and of course the community stamp for approval. Also, they keep improving things. For instance, now with 2.0.0, which of course is now all the releases are going to be stable, or final releases are going to be stable. They're still making improvements that they feel that they can do. For instance, on 2.0.0, they're changing the compiler. So they're going to use the Key2 compiler just to improve the compilation times for iOS, of course, along with other things. But one of the most important things is to give iOS developers almost the same experience as Android developers, which is to have fast compilation times and not waiting a couple of minutes for a framework to be generated. So talking about a bit of Kotlin multi-platform and just try to sum up, once again, it's Kotlin, a language that I'm going to say most of us love. And once again, I love these animations because they allow me to do this. It has low risk. You decide what you want to share, what makes sense to share. If something is not worth sharing, you're not sharing. If something goes terribly wrong, okay, you're not sharing anymore, and you use that code on Android side. Since you're not going to build the same thing over and over and over again for multiple platforms, you're going to have a faster development. You have a consistency. So you're going to have an one tech stack, which means that Android users, iOS users are going to use the same features, and those things like, okay, implement here a network request, and one of the apps decided to implement using a cache mechanism, the other app didn't use it, so one of the apps is faster than the other. These things disappear because it's going to be consistent. It also means that if you're going to have an issue or a bug, you're going to have a bug on all the platforms because they're using all the same code. But if you look things by the bright side, if you fix an issue, you're going to fix an issue on all the platforms, and that's great. And a really important thing here is that we have a really strong community support. I've lost count the number of times that I went to the Kotlin Lang Slack, and I'm going to send you these links afterwards. They're on the final slides. And they ask something on the Slack, and less than 2 hours after, someone gave me an answer. And it can be people from the community, it can be people from JetBrains. The community is really strong with Kotlin Multiplatform. I have to say that there are only from my years of development, there are two communities that I truly love. Which one is the Android community, and the second one, it's the Kotlin community that's really pushing things forward and wants everyone to succeed, and that's priceless. So I mentioned before the apps on production. I mentioned Space. There is also Netflix, a studio that is using multi-platform, and they released an article 2 years ago saying that they love the experience. Cash App, VMware, Yandex Maps, all of these big companies are using Kotlin multi-platform, and they're advising others to use. So we've been talking about Kotlin multi-platform so far, and there's a second thing that can help your life, which is called Compose. Compose, if you're not familiar with it, it's a new UI toolkit that was initially released by Google. So this was done 3 years ago. And if you go to the website, you can see a lot of cool things over there. They're going to say that it's really powerful. It makes your development time faster. You can create beautiful apps. And only all of this is true. I've been using Compose also since 3-4 years ago. It was still on alpha when I started, and it really helped my life as an Android developer. We made a couple of tests, and we realized that we're saving up around, in a year of development, we were saving up around 2 to 3 months of development after we had all our design system created. All of those steps were already done. We started to building apps way faster than we were building before, and shipping apps faster, which is great because the company could see more revenue on using one of these tools and to allocate time to learn, in this case, how to use Compose. So there are also a couple of companies out there already using Compose. The list is way bigger than this one, of course. You've got Google Play Store, you've got, I added the Twitter log and not X because I don't know the current state of things, but Twitter at the time was one of the main adopters. There's also a great blog post that was written last year about how they were using Compose, and they were advocating it for everyone to use. It allowed them to improve productivity, so write screens and features faster and with less bugs, which is always an important part. When you talk about Compose, you need to talk about the structure of Compose, namely the libraries. So you're going to have the compiler, the runtime, the UI, material tree, material, foundation, and animation. And we can group them into the stack that you see on the right. So you've got the Compose compiler and the Compose runtime. And then I'm going to group the rest of one in what I call the Compose UI toolkit, in this case for Android. So the UI, material tree, material, foundation, and animation. So starting with the bottom, the Compose compiler, basically, it's written in Kotlin. It's what's going to transform an annotation that you need to use with Compose, which is called the add composable. Every function that's going to build something on the UI needs to use this add composable. And basically, it's what the runtime and the compiler are going to use to be able to translate that code into something that you're going to see later on. Although it's an annotation, it doesn't use the annotation processor. So using Compose, it's not going to make your building times slower. Quite the opposite, to be honest. You're going to have less files and less functions, and so it's going to be faster to compile because of a set of optimizations that already exist. It's open source, so if you don't know what to do tonight and you have trouble sleeping, you can always go to this link and feel free to start reading the Compose compiler source code. We also have the runtime. It's platform agnostic. It doesn't know what Android, iOS, or even UI is. And you can see it as a tree management solution for the components that are going to be written on the screen. And now we have the set of libraries that Android uses. So as the name indicates, animation is used for animations to easily show or add animations like fade in, fade out, and so on. We've got the material tree, which is the material design system in its third version. which is great. It looks really, really good. And it's what most apps, Google Apps at least, are using nowadays. You've got the previous version, which was the material one. And you can always extend this design system and have your own, which is great because everything is so well structured that if you want to add your brand to your app, you just need to extend this and define things like the colors, the font, the styles, and so on. And when you're going to run your app, you're going to see the brand of your company on your app. You've got the foundation, so the way that you write things on screen. So columns are used as containers, text to display text, image to display images, and so on. And finally, you've got the UI, which is, for instance, when you're writing on the keyboard and you want to show something, you need to use the UI to get the keyboard, to get the keys, and to display the text on the screen. So on your side, on the left, you've got the compiler and runtime, and now you can have Compose on Android, on iOS, on the web, on the console. You can have Compose everywhere as soon as you have a Compose UI toolkit for that platform. And that's the great thing with Compose. It's important to mention that there are a lot of Compose versions out there. A lot of libraries built with Compose out there. One of the best ones that I really love and I use daily, it's the ones inside the Componist. A Componist is a set of libraries that were initially built by Chris Bain and then included on Google repository to be used by Google. I always advise if you want something that most applications have, just go to there and see if it's already built. Things like the pull to refresh, where you pull down your finger and load new data, were that good that they're now part of the Compose itself, although there's still a library here. They were incorporated in one of the previous ones that I've mentioned. Be careful with Compose and Kotlin. So if you're using the latest version of Kotlin, you should use the latest version of the Compose compiler. When you're updating the Compose compiler to select the new version, which is now on the 1.5.4, if I'm not mistaken. Be careful to guarantee that the version of Kotlin that you're using is one that's compatible with it, just to avoid any problem. If it's not compatible, you're going to see an error when compiling the project, but in any case, just to avoid that, check the documentation for that. So some key takeaways about Compose. I'm going to use this again, so sorry about that. It's Kotlin, a language that we all love. Once again, it has low risk, so you can still use Compose and XML. They're interoperable, and you can only use Compose or you can use only XML. It makes your development faster, it allows you to reuse a lot of code, and it's really simple to implement an app design system, which is something that when we were doing things with XML, it took us a lot of time, that it wasn't never perfect, and it could be complex to maintain throughout the years. Now that I'm talking about Compose, I wanted just to showcase a simple thing, which is called the Compose Multiplatform. And Compose Multiplatform seems to be here to stay. For desktop, it already reached a level of stability. And for iOS, it's expected to go better around next year. So I'm just going to show you the example that I built, that Unsplash app that you can find on my repository. And it's a really simple app. It's 2 screens. I'm showing a list of images that were downloaded from Unsplash API. You can search for something. Here I'm searching for my home country, Portugal. You switch between screen, you show these images and so on. So basically, I've built an Android app, and then with Compose Multiplatform, I made it run on the watch. So the same code is running on the watch. Well, almost the same code, because the watch had specific features like this scrolling that I wanted to implement just for the watch, but most of the logic is reused. And then for desktop, it's the exact same code. So the code that was running on Android, it's running on desktop. And you can see that's a desktop app because I'm just going to maximize the screen. Some point now, yeah, there you go. So you've got the desktop app for free, basically. And the exact same code is also running on iOS. And I forgot to mention, but also the font was changed. So it's a custom font that I'm using here on this project. The same app, the same look on all of the platforms. And most important, the same code base. So I'm using Kotlin Multiplatform for the business logic and Compose Multiplatform for the UI. Why? Honestly, because it was fun and because I could have it. And finally, for the web, there are two ways that you have here. You can use web and you can reuse the entire business logic. You can also reuse Compose, but it's not as easy because it still uses the DOM objects, or you can use WebAssembly for this. And with WebAssembly, you can just reuse most of the logic that you have on your UI. So you can have Compose multi-platform on all the platforms. So in this case, you have the business logic developed with Kotlin multi-platform and shared everywhere. UI shares UI, it's shared between Android, desktop, and iOS, and WebAssembly. So the second web part, but the initial version of the web that's using GS, it's also using Compose, but it's more difficult to share everything because it's using the DOM objects. How to share everything? So if you're an Android developer, you're familiar with the R class, which has references for everything. Or if you are an iOS developer, iOS also has different ways to access its resources. Or if you're a desktop developer, well, there are always different ways to access to resources depending on the platform that you're at. And all of these are different. Also, each platform has its own components. So imagine Android uses a lot of view models and the life cycle of your app and navigation, live data, all of those tools. This doesn't really exist on other platforms, or at least if they exist, it's not really the same thing. And what we want with multi-platform is just to uniformize this behavior and have the same behavior everywhere. So Kotlin Multiplatform is going to help us with this by just when you're running on Android, you're going to use the Android specifications. When you're running on iOS, iOS, and the web, and desktop, desktop. So if there's something that's not available in one of the platforms, you can always create your platform-specific implementation. There are a lot of libraries nowadays that already give you this support for free, and you don't need to worry about it. And of course, adding multi-platform to your project is going to really help you to share everything and to run the same code base everywhere. A couple of suggestions here. I've talked about the company's libraries. There are company's libraries multi-platform. They're developed by a user called CR10, and you can find on this GitHub. You also have the Compose image loader that's developed by KDSFDH VH. This tool is amazing. Basically, it gives you support for Compose multi-platform, and it's what allowed me to show images on Android, iOS, and the desktop and the web without any problem. You just need to import a library. Even the API is quite similar to Coil API and to Android API, so you can just use it and have the best result on your app. There's a Mocha resources. JetBrains is also implementing their own library for sharing resources. But for now, my advice is always to use Mocha resources because it has more features and allows you to do more things at this moment. I really love this library and I've been using for quite some time, and the results have been perfect so far. And you have pre-compose if you want to have the same navigation like the bottom bar. You can use pre-compose for this. If you're using view models from Android, you can also use them on iOS and desktop and so on. So let me just show you a simple example. Imagine that you want to share something between all the apps, so Android, desktop, and iOS. iOS moved from experimental to alpha recently, so we're getting there. And according to JetBrains, they wanted to reach beta somewhere around next year. So imagine that you want to show this text. If you're going to do it on Android, it should be something like this. You have your modifier, you set the text to be, or your container, your column to be centered in the screen, and you add a text, which is hello world. If you want to have it on desktop, it's the exact same thing. And if you want to have on iOS, it's the exact same thing. So the same code is going to run the same way everywhere. But this text string is hard-coded, and we don't want to use hard-coded strings. So the first thing, if you want to share the code, that you need to do is you create a new Kotlin Multiplatform project. You're going to call it shared UI, for instance, and you can move your entire Android code, if you want, all your UI to this shared model. Then we're going to see errors on some parts, and those parts need to be migrated to Compose Multiplatform and to Kotlin Multiplatform. You might need to replace libraries. For instance, if you're using Kotlin Android, you need to use the Compose image loader for multi-platform. You might need to change a couple of things. Then there is the things that are platform specific, like showing the text. So in that case, I was showing the text hard-coded. Now imagine that I'm accessing this text from the string file. The string file contains all the strings of your app, so all the text that you want to display. And it's really good because it allows you to have internationalization on your app. Okay, so if you change a language from English to Portuguese, for instance, and if you have a string file for English and a string file for Portuguese, Android will automatically replace the strings from one to the other without you need to do anything. So the strings resource usually is accessible by r.string, but the R class doesn't exist on the other platforms. So how can we use this feature without having a lot of if-else depending on the platform, or expect actual depend on the platform? A great tool for this is called the Mocha resources. And the Mocha resources allows you to reuse strings on each one of the platforms. So instead of having your string files inside of the res folder on Android, you're going to have your string files inside a folder called MR. And then you're going to have your English or your base language inside of a folder called base. If you're going to have your Portuguese inside a folder called PT, and if you're going to have in Spanish in a folder called AS, and so on. Then when you're going to access those strings, you're going to call the string resource from Mocha. And this string resource is going to receive, instead of the r.strings, is going to receive the mr.strings. So Mocha tries to create the same class file as R, but it's called mr and it's Mocha resources. And it's going to be, this one is going to be available for all the platforms to use. Be careful when you're using this on iOS. You need to copy these resources to the final app bundle. So you need to add a task if you want to use this on iOS. Now imagine that you want to display an image, and it does something like this. So you call a function called the painter resource. And once again, you use the R class. And in this case, use r.travel.mock or .touchlab. But you cannot use this on iOS and desktop. So you use, once again, Mocha resources to help us. And we're going to use the painter resource function from Mocha resources instead of using the one from Android. And we're also going to use the MR class that's going to have these images. So the only thing that you need to see here is that instead of using string resource and painter resource from Android, you're going to use the functions from Mocha resources. And instead of using R strings or R drawables, you're going to use MR image or MR strings. So where are we when we talk about the web? So the initial version of the web with Compose, as I mentioned, is the paradigm is a bit different. It's focused on the DOM rendering, and not only the components are available. So if you want to have something on the web, like the previous example, you still need to use Compose, but you're going to see divs instead of seeing a column, and you need to use the flex grow, the margin button, and use PX. So it's a bit more complex if you want to reuse everything, because you needed to create wrappers for this. Fortunately, you need to create a wrapper like this one. Fortunately, we started to have WebAssembly, and most of these issues disappear. So at this moment, on my opinion, the biggest drawback of using web is still the size that your GS files are going to have. So you want on web to have things really fast. This means that the files that your web page needs to load needs to be really, really small, and we're still not there. There are a couple of tricks that allow you to have this, like you can minify, you can use tree shaking and all of those things, and compress, of course, but it still takes some size that if you compare with doing things using other frameworks, it's way faster and it works a bit better. Also, it's important to mention that all the libraries that we saw before only mock resources as web support. So most of them web exists, but it's like best use scenario, not all of them have this support. So WebAssembly already has the support of sharing everything. If you go once again to the GitHub, you can see that I'm sharing the entire code with my web app, and it allows you to reuse code and to use a language that you already know on the web. Works without any major issue, at least on this simple project. Once again, the generated files can be a bit big, and not all libraries have WebAssembly. iOS, where are we? So this app is running on iOS. You already have apps in production using Compose Multiplatform on iOS. One of these examples is Write Code Kotlin, which was accepted by Apple. So that thing of Apple not accepting apps that were not built with Swift or Swift UI, it's false, because this app has been approved. Don't forget, of course, to enable the Kotlin native memory model, which is now enabled by default. And honestly, it works without any major issue. With the latest version of Compose Multiplatform, there was a huge improvement on the scroll. So now even if you use this app on iOS, you're feeling the same UX that you usually feel on iOS. Even the scroll, it's the same one. Although, of course, it needed to be created. It has the same look and feel and experience. I'm saying this, and I told you this on the beginning of this talk, but be careful about the demo effect. It's working fine on iOS. This is a sample application with 2 screens. I already have an application that also has similar things. I've got my settings on my app on Compose Multiplatform, and it's working fine. But depending on the app and depending on the complexity of the app, this might come with some risk. So be careful when doing this for iOS. Also, not all libraries support this. Font customization can be a bit tricky. Although it works with Mocha resources, you need to copy to the model file, like I've shown on the previous slide. And debugging one of these apps, it can be a bit complex. There is a plugin for Xcode that really allows you to do this, which is built by TouchLab, the Kotlin plugin, but it's not as easy as debugging a native application. I know that next year, 2024, JetBrains is actively working on this, but it's things that take some time to be perfect, and this is why Compose Multiplatform is not considered to be stable. For iOS, it's still on the alpha state. WatchOS, you can share the logic without any problem. You cannot share the UI for now. Perhaps this is going to exist in the near future. There is a pull request by JetBrains available, but so far there is no indication that it's going to happen tomorrow, for instance. Just to sum up everything, Multiplatform allows you to quickly create desktop apps. So Compose Multiplatform, if you have your Android app, you can easily have a desktop app, and this is great because I heard that not everyone has an Android, so they can just test your app on the desktop. And you can also try to sell this to a client, saying that you have a desktop app that works, and to earn some extra money for it or add it to the store. The cost of having this application on desktop, it's not that heavy, so it's quite simple. In a couple of hours, or let's say days, you can easily adapt your existing app, Android app, to desktop. And let's see, iOS and web are giving its first steps. 2024 seems to be bright for Compose Multiplatform and of course for Kotlin Multiplatform. So let's see if in the future we can have just our Compose everywhere. Some key takeaways: Kotlin Multiplatform is stable, Compose for Android and desktop is stable. From web, I'm adding beta-ish because it's not yet there in my opinion. Compose for iOS is alpha. Documentation and samples are being really improved by community and by JetBrains. They're releasing a lot of webinars about Compose multi-platform and Kotlin multi-platform, and the community and support is just amazing. The roadmap for Compose multi-platform has been released. As I mentioned, one of the focus is going to be iOS beta. And here just a couple of links and that you can access from the slides, and you can also see them from Speaker Deck just to know more about Kotlin and Compose multi-platform. Contact Kotlin, there is the Kotlin Slack. It's one of the best places to go, trust me. You've got also a book that I've written, so advertising here, you can also get this book. You've got Kotlin by TouchLab, by IceRock. You've got the Kotlin 1.4 online event. JetBrains is now releasing a set of webinars, so pay attention to JetBrains YouTube channel. And for Compose, we've got the Google samples, curated list from samples from Jetpack Compose, from fozo.github. There's a lot of people from the community that's also pushing Compose forward. I've got a couple of links here on Twitch from Jetpack Compose app. Joe Burst, George Castillo are one of the most known ones, but this is just a small list. There's a lot of people using Compose nowadays, and just search on GitHub and you're going to be amazed of how many projects there are. For Compose multi-platform and Compose, Kotlin multi-platform and Compose, I've got this sample that I've created for this talk. You have got the Droid Kotlin app by TouchLab, and you've got People in Space that was created by John O'Reilly, which is also a great project to see how everything works. So now I think we have some minutes for more questions. Feel free to just ask me anything for the upcoming minutes.
So I haven't heard of the term business logic before. So what's the difference between business logic and UI logic in this case?
Okay, that's a great question. So when you talk about UI logic, you're talking about showing your components on the screen. So imagine if you should display or not a button. So depending on a specific state, you're going to let's grab an example. So imagine that you're using, I'm going to say Instagram, and you've got that like button. And if you already had set the like on that image, you're going to show that button field. If you didn't, you're not going to show that button field, but you're going to show the outline on that button. So that's your UI logic. You're going to read a property called like, and you're going to see if it's true or false. And depending on that state, you're going to show it filled or outlined. Now, there is a lot of things that needs to be done before showing that button. You need to make a network request, you need to parse the response, and then you need to tell your UI that you've got to show this data. And that's the business logic. It's the part of accessing a server, accessing local storage, getting that information, process that information, and then send it to the UI. And this business logic of making your network requests, of parsing data, of storing data online, on computing data, this is what we call business logic, and this is what we want to share across all the platforms. So we don't need to do this over and over again. So because when you're developing for Android and iOS, you're going to do the same thing using different libraries, and this starts to be time consuming. If it's just a single developer, it's going to be boring for him or her just to keep doing the same thing over and over again. So sharing the business logic allows you also to save time, to guarantee that you're doing the same thing over and over again, and you're going to have the same behavior on all the platforms.
Okay, that makes sense. Thank you. Any other questions from anybody here? I don't see anything in the chat at the moment, so.
I have a question. Just for clarification, is like a Compose a framework of Kotlin?
No. So Compose was created by Google, and basically you can see it as a set of libraries. Okay, so it's not a framework, it's more of an SDK also that you can just import to your project. And since Android has this support, you can build your UIs using Compose.
Okay,
So,
okay, thank you.
Yeah, basically you import these libraries and you have access to a lot more functionalities of building your UIs. You have functions that you didn't have before.
Yeah, so it's not like a framework where you run into trouble of the framework.
No.
Yeah, okay.
No, nothing like that. If it was a framework, I'm not a fan of frameworks. I really prefer having just import libraries and have features, because with a framework, you start to be dependent on that framework. Of course, you can also argue that you're going to be dependent on a library, but the library represents a small thing on your project, while the framework might represent your entire project.
I'm just gonna say it's like how did you start out with like a mobile development, and like what was your learning curve for it? Because when I first started learning like mobile development, it was quite hard for me. There was a lot to learn, and I didn't know where to look, whether to do a framework or whether to like do certain libraries for it. Like, what's the learning curve for it? Is what I'm asking.
Okay, that's a really good question. So it depends a bit on the platform. I'm going to talk a bit about Android. I feel that nowadays, all the platforms that you want to learn, you've got too much information online about it. So, and you have a lot of opinionated information online about it. So, out of curiosity, when you start working on Android, I think it's like every 15 days there are like 77 libraries being released, and it's impossible to keep track of everything. And the first thing that I think it's important is, although you have a lot of things to do, a lot of things, you don't need to know all of those things on your project, and it's not important to have all of those things on your project. My advice when you're starting to develop, in this case Android, there is a set of code labs. Before code labs, you've got a set of training courses that are available on android.com. And if you want, I can send you the link afterwards. And that this training course basically tells you how to develop your first application. They show you how to use Kotlin, which is a language that might not everyone know, although we all love it. But jokes aside, it might be a new language that people don't know. And the first examples teach you how to use Kotlin. The second ones, they show you how to create a simple screen, and the second tutorials that they have there, they create things more advanced. So my first advice is to go to Android training and start one of those courses. And they go step by step, so it's quite easy to follow everything that they have there. It's following the latest practices, so it's a great tool to start learning, and it's free, which is also great. Secondly, if you want to learn about something specific on Android, there's a thing called Code Labs that you can just search for Google Code Labs and access a list of them. And then you can just search for something specific. Imagine working with the paging library, and they're going to give you a code lab, once again, that you can go step by step and implement that on an app. And the great thing about all of this is that you've got a startup project, so you know how to start, and they also have a final project. So you have something to compare to when you finish the code lab, and if something is not working, you can always compare with the final project. This is always my advice if you want to start learning Android. Then you asked about the learning curve. This is always a trick question. I always say that it depends a bit on your background. So imagine that you're coming from iOS to Android. I would say that the learning curve is really small, in the sense that Kotlin can be quite similar to Swift, and even Swift UI is similar. The reasoning, the logic on how you build the UI, it's similar to the one in Android. So you just need to look for the syntax in order to learn how to do things on Android. If your background comes from, for instance, the server side, this is going to be a lot more complex, and the learning curve will exist because you're not familiar with building UIs, and you need to learn a new set of paradigms. I would say that if you have, like, in 1 month you can create something simple, in 2 months you'll be able to create a bit more complex application, and from 3 to 6 months you're going to be able to develop applications more complex. Of course, it depends. Complex, it's like an abstract word and depend a bit on the things, but I believe nowadays with Compose, which I don't know when you started, but before we were using XML, I feel it's more tricky. But I would say that you can see results after 1 month, and after 1 month of working every week, you're going to be able to start developing without thinking, okay, let me just search, oh, this is done, oh, this is done, oh, this is done this way. Now you can start developing your app without that much research, which is always helpful and faster to implement your ideas. I also advise people when they want to start working with Android. I know this might sound a bit cliche, but I still feel it to today that's true, which is start by creating a simple app. And that app it's better to solve something that you need. For instance, I remember that a few years ago I wanted to learn a specific technology inside Android, and I was having some troubles with different time zones, so I created an app for that. It was like a 2-screen app, really simple, but it allowed me to test things and learn things. And since it was solving one of my problems, uh, working on it and learning from it made all the process better. Because when you're learning some new thing, I know that this learning curve can sometimes affect your moral, because sometimes you take more time, sometimes you take less. And developing something that it's going to be useful for you, it also helps on the process.
Thank you very much. Thank you very much.
Also, if you need any tips on learning Android or Kotlin or Compose multi-platform, also feel free to reach me on Twitter, for instance. I have the link at CFOnsmart. You just need to search me, Twitter/X nowadays. And I can easily point you toward any resources or can take you any doubt that you might have. This is valid for everyone, by the way.
I just had a quick follow-up question. So I've noticed that for UI stuff, there's like a lot of frameworks and libraries that I guess keep coming out, as you mentioned. So on Android, there was Xamarin, there's React Native, there's Flutter, and then on desktop you have like Qt and like a bunch of other things. So I guess my question is there a reason why there's so many of them? Like I never understood that personally.
Okay, that's a great question. And I think the answer that I can give you is we keep seeing new ones because the previous ones didn't fill everyone's requirements. So, so for instance, talking about mobile mostly, for instance, we started with Ionic, with Xamarin, and so on, and each one solved a problem that the previous one had and added a new problem. So Flutter, when initially started, for instance, a lot of people like the idea of Flutter, although the language, it was Dart and people were not familiar with it, but it solved a lot of problems. It was faster. It solved a lot of problems that, for instance, Xamarin had. But people are still not 100% convinced, although there are a lot of Flutter developers out there and a lot of applications on Flutter. I feel that they weren't still convinced, and this is why Kotlin multi-platform was launched. It's all of these tools try to share everything. So Ionic, Xamarin, Flutter, React Native, they all try to share everything. But what if you just want to share a small part? So only the business logic, which is what Kotlin multi-platform wants to do. So each one of these frameworks tries to tackle the problem of sharing your code differently. And this is why we keep seeing new ones. And honestly, I think the ones that were launched like 10 years ago, we still see them today. They might not have the same amount of users, but we still see them today, and they're still having users. So their use cases that are still valid for a lot of developers. And I'm saying this, and perhaps next year we're going to have a new framework being launched. There's no such thing as too much frameworks, it seems.
Yeah. Awesome, thank you. Any other questions from anybody? Going once, going twice.
I just want it's not a question. I just want to, when are we going to design a framework for creating frameworks on mobile?
Yeah, that's really good questions. Let's I don't have free time for that.
All right, so if you don't have any other questions, I guess you can close it off.
Let me just say that thank you everyone for being here. It was a pleasure to talk about Kotlin and multi-platform and compose with all of you. Thank you so much for being here on a Friday evening.
Yeah, thank you everyone. Thank you, Carlos, for agreeing to do this for us. It's great to see people that are very passionate about all of these things.
Just my final love for everyone.
Does that happen automatically, or do you have to press a button to do that?
No,
On
it's
your...
automatically, it's a Mac feature. It's on the new Mac OS.
Oh,
And
okay.
basically, if I do things like this, or I think there's also this one, it's going to show a thumbs up somewhere.
Oh, okay.
Not all of them work perfectly, but this one I found that it's quite easy and it works every time.
Oh, awesome. I guess that's computer vision.
Yeah.
All right, so I'll just go ahead and stop the recording and